Solve the triangle, express the angles in degrees and minutes. It looks like this angle was already given to us in degrees and minutes, and it looks like it's probably rounded. It looks like it is rounded to the nearest tenth of it, to the nearest 10 minutes, which this means we should be dealing with 3 significant digits. And that's exactly what this one is expressed as. So in any case, the remaining angle we can actually figure out. We know that these should sum up to 90 degrees. So let's figure out how we would do that. 71 plus 20 over 60, that's 71.3 repeating. So 90 minus 71.3 repeating looks like this. It's 18.6 repeating. And that 0.6 repeating, so this is 18 degrees with some portion after it. If I was to just take that portion after it and multiply that by 60, you can see that's 40 minutes. So this is 18 degrees and 40 minutes. There's other ways that I could have done that. This is just, kind of quick and dirty. Alright, so I know, let's see, what do I want to find? I want to find the hypotenuse and this other side here. I'm going to be using this as my reference angle. And let's say, well, this side right here, if this is my reference angle, then this side is going to be the adjacent. And this is going to be my hypotenuse. So SOHCAHTOA. I have my adjacent and my hypotenuse. That means I'm talking about a cosine. So the cosine of my angle, 71.3 repeating, equals, or I could say 71 and 20/60ths, equals my adjacent, which is 3.27, over the length of the hypotenuse, which is unknown in this case. So I'm just going to call it C. Okay, so that means if I want to solve for C, this C is currently in the denominator, so I'm going to multiply both sides by C. C times the cosine of 71 and 20/60ths equals 3.27. Okay, now I want to get rid of this cosine of whatever. Cosine of whatever. So C is equal to 3.27 over the cosine of 71 and 20/60ths. So I'm doing kind of all the algebra here before I've plugged anything into the calculator, so I'm not having to do any rounding at all, and let the calculator kind of do all that for me. So I'll do 3.27 divided by parentheses cosine, actually I don't need parentheses there, cosine of 71 plus 20 over 60. I did want the parentheses around the 71 degrees 20 minutes though. So do that, I get 10.2 something. This is rounded to the nearest hundredth of a centimeter. This one, if I keep it to 3 decimal places, at 3 significant digits, would be 10.2. I guess that's what I'll do. So this would be 10.2 centimeters. And as far as B is concerned, I'm going to use B. To find B, I'm going to use this as my reference angle, and again, this side that's adjacent, this is the opposite. So if I'm using this as my reference angle, I'm then referring to my opposite and adjacent, which is the tangent. So the tangent of 71 and 20/60ths is equal to B, opposite over adjacent, so B over 3.27. Looks like on this one I can just get away with just multiplying both sides by 3.27. So 3.27 times the tangent of 71 and 20/60ths is equal to B. So I can just type that in there. There's no division necessary here. Type that into my calculator. I get 9.67, but when I round this up, it becomes 9.68. And of course, you can see I have the 3 significant digits there. So I have my 3 angles, and I have my 3 sides. This triangle is solved.